Okay, so now let's look at the circle now. Let's look at the circle. So if I have a circle like that, this is a circle here. This is a complete circle. A circle has basic features. If I have a line that's drawn from the circumference to the center, that's the radius, right? This outside boundary is the circumference, and that there is the center. So a line that's drawn from the circumference to the center is the radius. A line that's drawn from circumference through the center to circumference, this one is the diameter. So that's not the radius, it's the diameter. So from what you're seeing, the diameter is equal to 2 times the radius, right? The diameter is twice the size of a radius there. So that's a diameter and that's a radius. Let's draw the circle again and make some other observations. So we agree that this boundary here is known as the circumference. But a piece of the circumference, perhaps from there to there, this piece that's in red, this is what you call an arc. So an arc is a piece of the circumference. If this is the full circumference, an arc is just a piece of the circumference. If you have a line that's drawn from one part of the circumference to another part of the circumference, and it doesn't pass through the center, this is known as a chord. So a chord is a line that's drawn from one part of the circumference to another part of the circumference. An arc is a piece of the circumference. Now, whenever a chord is drawn, the circle is actually divided into 2 segments. So you've got this part here, that's a segment, the smaller segment, and then you've got that bigger part there, that's the bigger segment. So whenever a chord is drawn, it cuts your circle into 2 segments. So this is just a few things you need to understand before we go into our theorems. Now I think we're ready for our theorems. So in this video, we're going to go through the first 3 theorems. We have a total of 8 circle theorems. We're going to go through the first 3. So let's go through the first one. So theorem 1, right? The theorem says that angle subtended by an arc at the center is twice that which it subtends at the circumference. So an angle subtended by an arc at the center is twice that which it subtends at the circumference. So let's see what that looks like. If I have a circle like this, and this is the center of the circle, right? So just an arc there, piece of the circumference. If this arc shoots 2 lines towards the center, the 2 lines will form an angle at the center there. If the same arc shoots another 2 lines which meet at the circumference, an angle is formed at the circumference. So what do we know? This arc from there to there is responsible for the formation of the angle at the center. It's also responsible for the formation of the angle at the circumference. So this one, this angle is at circumference, and then that one is at center. What our theorem is telling us is that the angle at the circumference and the angle at the center have a relationship such that the one at the center is 2 times the size of the one at the circumference. the one at the center is 2 times the one at the circumference. So if this is 80, that's 40. If this is 60, that's 30. If this is 40, that's 20. If this is 30, this is 15. The angle at the center will be twice the one at the circumference. Now, the same situation may have a slightly different appearance, right? This is our center, and then we have some sort of appearance like this. In this case, our angle at circumference is this one. This is our angle at circumference. But our angle at the center must be the one on the outside of this diamond-like shape, not the one on the inside. This angle is related to the angle on the outside. So if this is x, that is 2x there. So if this is maybe 200, that would be an angle of 100 degrees. So that's the first formula. The first theorem simply says that if we have an arc, and an arc is responsible for angle at center and responsible for angle at circumference, right? The one at the center will be twice the one at the circumference, right? Both angles have the same parent, which is this arc here. So that's theorem 1. Now, let's proceed to theorem 2. So theorem 2 angles subtended by the same arc at the circumference are equal. So angles subtended by the same arc at the circumference are equal, right? So if you have a circle like this, and then again you have two angles coming from an arc. So the first angle is going to go like this. Two lines meeting at the circumference, they form an angle. From the same arc, right? This is possibly the arc. We have two lines coming from there and forming an angle. So both angles are coming from the same arc, and both angles are going to the circumference. These angles will be equal in size. So if this is 30 degrees, that's 30 degrees. If this is 40 degrees, that's 40 degrees. If this is 50 degrees, that's 50 degrees. This is simply saying if I have one arc and the arc is sending two angles, both of them going to the circumference, right? Both of them are going to be formed at the circumference. Then the angles are equal. Whatever that angle is, that angle is also. So this arc has basically given birth to twins. So this and that angle have the same parent, and they are twins. Now the same theorem can be extended to say equal arcs subtend equal angles. So if two arcs are equal, then the angles they form are also equal. So if I have a circle like this, and then I have something like this. If this arc here from there to there, and that arc there from there to there, if these two arcs are equal, then the angles they form are also equal. So these two angles will also be equal. They are formed by equal arcs, so they are also equal. Okay. Now let's go to the third and the last theorem for this particular video. And this is theorem 3. Angle subtended by a diameter at the circumference is 90 degrees. So angle subtended by a diameter at the circumference is 90 degrees. So if we have a circle like this, we described what a diameter is. A diameter will be a line that goes from circumference, passes through center, and goes to circumference again. Now, if this diameter from its two ends, so it starts there and ends there. If these two ends shoot two lines at the circumference, so one line there and another line there, where the two lines meet, they'll always form a 90-degree angle. Okay, so even if they shoot two lines in another direction, right, they shoot two lines coming down like that, 1, 2, as long as these 2 points are coming from the ends of a diameter, which is what this is, then they'll form 90 degrees. So a 90-degree angle will be formed when an angle is subtended at the circumference by a diameter. So those are our 3 theorems, right, that you need to understand. So you can always run through the video again just to make sure you have perfect understanding of the theorems before you answer the questions.